morning, boys and girls. We are going to be learning more about sound today, mainly focusing on musical instruments and tuning things. So I know a lot of you are already familiar with some of the things that we'll be talking about if you happen to play a musical instrument and take lessons. So first of all, I want to spend just a short time talking about absorption and reflection, which we talked about with our light unit. Absorption is when dark colors like absorb light and it's not reflected back. And then reflection, like a mirror, reflects back the light. So there's actually absorption and reflection with sound waves too. Now, reading from this book, and actually I'll go ahead and present it as well. Now, some materials take in or absorb sound waves that strike them. Think about walking on a thick rug. Your footsteps are quiet. That's because soft materials absorb sound waves, like this carpet. Okay? That carpet, if you walk on it, it absorbs the sound and your steps sound quieter than if you walked on hardwood floor. So certain materials are used to absorb sound. For example, a movie theater oftentimes has thick padding on the walls. So with that thick padding, it absorbs the sound so that if two theaters are side by side, you only hear what's happening in that one theater you're in. Foam is also used to absorb sound. Some people use foam earplugs to keep their ears safe while doing noisy jobs. Other people wear foam earplugs at a concert or when they're sleeping, if they are light sleepers. Other materials reflect sound waves that strike them. When sound waves reflect, they bounce off of a material. Materials that reflect sound waves are usually hard and smooth like this. That will reflect sound more. Think about walking in hard shoes on a hard wooden floor. Your footsteps are very loud. That is because the wooden floor reflects the sound of your footsteps. So this reflects, this absorbs. Okay, now here is another way of reflecting. An echo is a reflected sound that we can hear. Scientists sometimes use echoes to explore places they cannot see. They can study and map the ocean floor actually using echoes. Scientists can send sound waves toward the bottom of the ocean. Then they measure how long it takes for the echo to get back to them. So as they send a sound wave down, identifying how long it takes to get back is what we call echolocation. Then the more time it takes, the greater the distance to the bottom. This technology is called sonar, which stands for sound, navigation, and ranging. Okay, so sonar is that scientific ability to see how far away things are. Now, buildings may have materials that are meant to absorb or reflect sound. For example, in a concert hall, some materials reflect sound towards the audience. So in a concert hall, if you go to an orchestra concert, for example, you want that sound reflected to you so you can hear it clearly. Other materials absorb sound, like a movie theater, as we mentioned. That helps us to not hear outside noises. So why does a ball bouncing on a sidewalk sound different from a ball bouncing on grass? Because on concrete, that is a surface that would reflect sound, whereas grass is kind of like a carpet. It will absorb the sound. So concrete and this like wooden desk, they reflect sound versus, here I've got a little blanket on my lap. If I have, for example, one of these tuning forks that we're going to get into soon. On a blanket, it absorbs the sound much louder on a desk like this because it reflects sound. Okay, next little section, musical instruments. Now, musical instruments can be grouped into three main groups. Three types are percussion, wind, and stringed instruments. Do any of you play a percussion instrument? I know Tig the other day showed us a little drum that he made with part of a balloon wrapped on top of a toilet paper roll, just like a little handmade drum. That was an example of a percussion instrument. There's wind instruments like this, the clarinet or flute, and stringed instruments would include guitars and violins, for example. Now, percussion instruments vibrate when they are shaken or struck. For example, drums, tambourines, maracas over here, and cymbals are percussion instruments. So they vibrate when they're struck. So there's some form of hitting, and then that makes a vibration sound. The pitch of a drum depends on its size and shape. Most drums have only one pitch. That's pretty different than most instruments. But yeah, a lot of percussion instruments just have one pitch. They're not necessarily simpler to play, but it's just different. Now, wind instruments make sound using vibrating air. Trumpets, clarinets, saxophones, flutes, trombones, and tubas are wind instruments. So this is an example of a wind instrument. That's a clarinet. You blow air through it, and that vibrating air makes the sound. A wind instrument is shaped to contain a column of air. A musician blows into the instrument to make the air column vibrate. The musician can change the length of the air column by pressing on valves or holes on the instrument. This is how the musician makes notes with different pitches. So this will change how long the column is, and that's what changes the pitch. Now, stringed instruments make sounds when their strings vibrate. Musicians can pluck strings or move them with a bow. The vibrating strings make the body of the instrument vibrate and make music. Violins, guitars, banjos, harps, and cellos are all stringed instruments. Long, thick, or loose strings vibrate more slowly. So if it's long, thick, or loose, they make sounds with a low pitch. Short, thin, or tight strings vibrate more quickly. They make sounds with a high pitch. A musician can make a string tighter or shorter. So that's something you can actually change. If you want it to be tighter, that's going to make it a higher pitch. These are ways to control the pitch of a string and play many sounds. Musicians sometimes use a tuning fork like this when they adjust the pitch of their instruments. When a tuning fork is tapped, I don't know if you'll probably not be able to hear that, but it vibrates at a specific frequency. This makes a sound with a certain pitch. A musician then can tune the instrument to sound the same as that pitch. So it helps you to hear what pitch you want your string to be at, for example. Okay, so that is all for this little short lesson. You are going to have another video that has some information about how you can have sound from a guitar. I know some of you have guitars at home, or if not, you at least have probably played an instrument before, whether it was in a music class, like at school in years past, or maybe you've played an instrument with specific lessons. So I hope that this will help you to relate what you know from that to our study of sound. So I'll have that posted in Brightthink for you to do as well. Have a wonderful day, boys and girls. I'll talk to you later. Bye.